Hello, and welcome to another Orange Coast College mathematics video. In this video, we're going to look at how to find the least common multiple of two polynomial expressions. Now, I'm going to assume that you are comfortable finding the prime factorization of two numbers, and that you know how to factor. All right, let's start with an example. When we have two numbers, the least common multiple of those two numbers is the smallest number they will both evenly divide. Now, the way we can figure this out, although you might already know the answer in this case, the way we can figure this out is to look at the prime factorization of each number. So we look at 8, and 8 is just 2 cubed. And 12 is 2 squared times 3, okay? The way we see the least common multiple is we look at each unique prime in both numbers, and we need from each number, we need whatever the largest power of each unique prime is. So if we look at our unique primes, we have 2 and 3. But we need the largest power of each that's available to us. So our least common multiple, it will be the largest power of 2 is 2 cubed, and the largest power of 3 is to the first power. So our least common multiple will be 2 cubed times 3, which of course is 24. In this example, we wish to find the least common multiple of two monomial expressions. Now we do it the same way we did as in the previous example. We simply look at each expression, we find the prime factorization for any numerical factors, and then our least common multiple, we look at each unique type of factor, and our least common multiple will be the largest power of each unique factor. So we start by factorizing 6xy cubed. So 6, of course, is 2 times 3. And then we have xy cubed. Then we move on to the next one, 10 x squared y squared. 10 is 2 times 5, x squared y squared. All right, so our numerical factors, we have a 2 in each, so we need a 2, but they're both the first power. We have a 3, and we have a 5. We need each one of those. Those are all unique. They're all to the first power at most. We need those. Then we move on to the variable factors. We have an x in both. So the largest power for x is x squared. Okay? And we also have a y factor in both. The largest power of the y factor is y cubed. So our least common multiple, we take all of those things we underline. So we need 2 times 3 times 5. We have an x squared and a y cubed. So our least common multiple will be 30 x squared times y cubed. Now we wish to find the least common multiple of two polynomials. Now the first step, if I want to find the least common multiple of two polynomials, they need to be factored completely. So u squared minus 1 is a difference of squares, and so it can be factored into u minus 1 times u plus 1. U squared plus u, you can factor out from each term u, so you get u times u plus 1. And again, now we look at each unique factor. We take the largest power of each unique factor available to us, although in this case, all of the factors are to the first power. So we notice we have a u minus 1, and we also have a u plus 1 in both. We only need one of them. And we also have u. So the least common multiple will be u times u minus 1 times u plus 1. There's no need to multiply it back out. In many problems where we need to find the least common multiple, we'll end up needing to simplify by canceling factors. And so in this particular instance, there's no point in multiplying it back out. Here's our final example. Again, similar to the last one, we must start by factoring each polynomial. So the first one, x squared minus 2x minus 3 is a quadratic trinomial, and we factor it again by looking for two numbers that multiply to give you negative 3 and add up to negative 1, in which case we will get x minus 3 times x plus 1. Okay. Then for x squared plus 4x plus 3, we're looking for two numbers that multiply together to give me positive 3 and add together to give me positive 4. That, of course, is 3 and 1. And again, we're looking for our least common multiple will consist of all of the unique prime factors that we have here. So what are our unique prime factors? We have an x minus 3, we have an x plus 1, and we have an x plus 3. Again, no need to include this x plus 1 because we already have that unique factor counted, essentially. So our least common multiple will be x minus 3 times x plus 1 times x plus 3. And that's it for finding the least common multiple of two polynomial expressions. Now, this will be a really useful skill when we need to add rational expressions together, so practice this as much as you can. All right, until next time, have fun.